Hello and welcome to my video. Today I'm going to explain what is a convolution neural networks. Basically, convolution neural networks is a variant of multi-layer perceptron or a artificial neural networks. So what makes this different from a artificial neural networks? Because it contains some convolution layers that actually detects patterns, features from an image. So basically, networks mostly used for image classification, but can also be used for data analysis and classification of different kind of data. So let's see a simple overview of a convolutional neural networks, or also known as CNN or a convent. So here you can see there is basically uh, two main part of a convolutional neural networks. So these four layers we can see these layers are convolution layers, and these layers are fully connected layer. We can see that, and firstly we can see a input image. It is an image from MNIST dataset. MNIST dataset contains handwritten digit from 0 to 9 images with a pixel size of 28 by 28. So uh, firstly, we're going to see a overview of how convolution neural networks work, and next we are going to see how a convolution happens on a pixel of images. So these convolution layers actually detects patterns and features from an image. Then it passes it to the fully connected layers, and fully connected layers is actually artificial neural networks. Fully connected networks actually classify the image into our desired classes. Like in image, as I said, there is 10 classes of images from 0 to 9, handwritten images of 0 to 9 digits. So there is 10 class. So how many class do we have? 10 class. So we're gonna have a the last layer, the output layer, will have 10 nodes. So firstly, what happens, it takes the image, then it extracts features or patterns from the image, and it passes it to the uh, deep fully connected layers. So before that, to pass this convolutional output of the convolutional layer to the fully connected layer, we have to flatten the output of convolution layer so it can be fed into the fully connected layers. As you can see, there is just one hidden layers, uh, but a fully connected layer contains thousands or hundreds of hidden layers, and the output layer, as I have said, will contain number of nodes. The nodes of the output layer will contain uh, the number of classes we want to classify. So this is the basic structure of a convolution neural network. So whenever here we can see only two convolution layers followed by a max pooling layer. So we're going to get into that in a bit. So you can see we have a this is the first convolution layer. It contains a filter of 5 by 5. Filter is also known as a kernel. So the filter could be a 3 by 3 filter or a 2 by 2 filter, 5 by 5 filter. It doesn't matter. It will have to define it depending on your data set. So there is only just two convolution layers, but we can add thousands of hundreds of convolution layer neural networks. So each time we use a convolution layer, we have to define number of filters and the filter size or kernel size. And here you can see the kernel size is 5 by 5. And each time we use a convolution layer, it will be must be followed by a max pooling layer. So we're gonna talk about max pooling layer in just a moment. So we're gonna come back to the image. Let's first have a look how a convolution works. So we know that images are represented in multidimensional arrays, or sometimes called tensors. So this is a simple representation of an image. This is not representation of a M-listed image, but for a simple demonstration purpose, I have taken this image. Just consider it as a multi-dimensional array, and it contains pixel values. And suppose we have a 2 by 2 filters. The basic operation of the convolution is how I'm going to explain later. This just this filter will start from this 2 by 2 layer, 2 by 2 filters, and then